Hello, our fabulous chemistry minions.
MoNaCo and Milks are here, finishing up our Unit 12.
Ooh, last video of the year.
Yeah, aside from you paying attention how to make your own castle self-studies.
Yeah. We might have to put up some fun ones just to see if we can catch it and see if we can get an extra watch in. But you know,
Yeah.
let's do Half-Life.
And we are going to be revisiting a topic that you saw in your earth science classes.
Sure, and there's no equation for us. There's nothing in your reference tables,
Yeah.
so we're going to talk about a little process. Hopefully you utilize that.
Method, right. So are all radioactive nuclides created equal?
Absolutely not. They have different modes of decay, first of all, and then they have these different signatures called half-lives.
Okay, so how long exactly will something be radioactive for if it's each got a signature?
I'm going to say indefinitely.
Ooh.
Well, think about it.
Good. I love it.
If I lose half every time,
right,
am I ever going to reach zero?
No.
There you go. So I'm always going to be coming closer and closer to the wall. If every time I move towards the wall, I go halfway there, I'm never going to really touch it, am I?
Wow. This is something to deal with logarithms and asymptotes and
it's coming.
Algebra.
Here you go.
Because you can't ever reach that value, but you can get incrementally closer to it.
Correct.
We're not going to do calculus.
Nope.
But that is the fundamental underlying
limits
factor in the radioactive decay equation, which, as we mentioned, we don't use. So we use a chart method. And this is the chart.
So you're going to want these 5 headings,
Yep.
or 4 headings: half-life, time elapsed, mass of your sample, and the fraction remaining.
The cool thing about this chart is you can fill out the first and last column
right off the bat.
Every time. The time elapsed and the mass of the sample
depend on the problem.
So here we go. We always start out with 0 half-lives.
Then 1.
And we count in whole number.
Then 2.
1, 2, 3, 4, 5.
Right. And so if I'm at the 0th half-life, the whole thing is there.
1.
Then every time I do 1 half-life, that's half. And so times another half is 1/4, and then 1/8, and then 1/16, 1/32,
a 64th, 128th, a 256th, but you'll never get to 0.
Right. Let's do some practice problems and see how this all works out. So do you want to go ahead and fill out your numbers ahead of time before we even read the problem?
I will, and I'm going to use green because we're talking about radioactive things.
Oh, fine.
Yeah.
So half-life, 0, 1, 2, and 3. And then your fractions are going to be 1, 1/2, 1/4, and 1/8. And now we got to dig into the problem to fill out the rest. So it says a radioactive element has a half-life of 2 days. What fraction would remain after 6? So I got to take this time elapsed to 6, and I can figure out what the fraction is.
So
ready?
0 half-lives have gone by.
0
time has elapsed.
And then 1 half-life is 2 days.
Because it told us.
And so then 2 half-lives will be 4 days. Add 2 more on. Add 2 more on, and I'm at 6 days. And oh, look, I hit 6 days. What fraction would I be remaining? 1/8. It doesn't give me a mass in the problem, so I'm good there.
So you don't use that part of the chart?
Not this time.
Not this time.
Okay. Any questions? I didn't hear any. Okay, moving on. Next one. Let's fill out, well, he fills out the first 2. I'll start reading the problem. Radioactive element has a half-life of 10 years. How many total years have passed after the sample has decayed to 1/4? So I see my 1/4. I got to get down into the half-life number 2. You see that? So let's do time elapsed. The time elapsed for 0 half-lives is 0, and then it's going to be 10 years, and then 2 half-lives is going to be 20 years, and I'm done. I see 1/4 is at the 20-year mark, and that be our answer. Takes me 20 years to have 1/4 of its original mass.
And you can see in this chart format, you actually produce more information than you need. Because you can then predict, well, after 3 half-lives, it would be taken 30 years, and an 8th would have been there.
Correct.
So, yes, it does give you extra information, but it really rounds out the whole picture.
Yeah, we're not really doing too much. This is a really good, we would have been doing mass if we could, if we were really doing too much, and you can't because I don't even have it. So 2 more and we're done. Filling out our knowns, radioactive element has a half-life of 5 years. How many half-lives have passed after the sample is decayed for 1/8? So you see 1/8, I got to go all the way down to 3. So I'm going to start at 0 time elapsed, then 5, add 5 more on is 10, add 5 more on is 15. 15 years, 1/8 will be remaining. That is our answer. Are we getting the hang of this yet?
And also, the same exact question could be asked. A radioactive element has a half-life of 5 years. How many half-lives have passed after an example is decayed to 1/8 of its original mass? So this is actually 3 is the correct answer. If you said 15 years, you would be wrong because it's not asking you how much time has elapsed.
Good catch, Mr.
It's
MoNaCo.
asking you how many numbers of half-lives have elapsed.
So we didn't even need to
all
fill
the
in that.
information is in there. Yeah.
Yeah, that's awesome.
Yeah.
See how
So
we do?
moving
All
on.
right, last one. Oh, that was the last
Got
one.
it. So the only thing that you will see in the practice is that we're actually going to start throwing masses at you.
Right, so let's just do one real quick verbatim then. If I started with 50 grams, I went through one half-life, I would have how much left?
25.
25 grams. And then if I go through another half-life, I'm going to have 12 and a half. So we can fill in the grams by cutting the mass in half. 12 and a half is 6.25.
Right? So that is what the whole origin of the term half-life kind of relates to. How much time does it take for half of the mass to change into another mass, a different element, a different isotope?
Right, so now it's just a matter of reading the problems, filling in your chart, and answering the correct question that's answered.
And the other thing about half-life I just want to let you know is that if your sample started out as 10 kilograms, and the half-life goes in at 5 kilograms is now the original, the other 5 kilograms, it's not like it's just evaporated into thin air.
It's just a new thing.
It's just a new element inside the same sample that you had. So the whole overall mass of this chunk of radioactive material on the scale after 5 years or whatever really hasn't changed much, but the identity of half of the material has changed into a different element through a natural radioactive decay.
And we're all done.
That's it for the standards of reagents chemistry.
Happy chemistry and reviewing for your final. See you.
Boy. Bye-bye.